There's a part of us that thinks we've already figured out the sun. We learn about it early on, hot, bright, 93 million miles away, been burning for billions of years. It feels stable, predictable, almost boring. But that's not really true anymore. Right now, the sun is hitting the most active point it's been in over a decade. And it's not just sending off flares and storms, it's doing things we didn't think it could do. One NASA probe flew right through the chaos and saw something strange, something we've never caught in action before. This wasn't just another solar flare. Multiple eruptions slammed into each other, fused together, and created a magnetic ripple so powerful it bent part of the sun's outer layer. Scientists are still trying to figure out what that means. And here's the part that's bothering a lot of them. This kind of behavior doesn't really fit the models. It's not supposed to happen like this. So now we're left with a question we haven't had to ask in a long time. Do we actually understand how our own star works? Or has it been hiding something in plain sight? You probably haven't noticed anything unusual when you look up during the day. The sun still rises and sets like clockwork. No changes to the color, no warning signs in the sky. But behind that calm appearance, something big is happening. We're right in the middle of something called solar maximum. It's the most active phase in the sun's natural cycle. A period when the magnetic field gets tangled, twisted, and unstable. And when that happens, the surface becomes restless. Sunspots form, flares erupt, and huge clouds of charged particles get hurled into space at high speeds. This cycle has been going on for billions of years. It repeats roughly every 11 years, like the sun breathing in and out. One cycle ends, the next begins. And each time the magnetic poles flip. North becomes south and vice versa. It's not instant and it's not clean. The flip takes time. And during that period, the sun becomes chaotic. Right now in 2025, we're at the peak of solar cycle 25. That means the magnetic field is tangled up more than usual. The number of sunspots is going up. And those sunspots, they're not just dark patches. They're active regions that store enormous amounts of magnetic energy. Think of them like pressure points on the surface. When the pressure builds too much, something snaps and you get an explosion, a solar flare, or worse, a coronal mass ejection. Solar cycle 25 wasn't expected to be this strong. When it started in late 2019, predictions said it would be weaker than the last one. Quiet, mostly uneventful. But that's not what's happening. Over the past few months, scientists have been seeing more sunspots than they expected. And they're not evenly spread out either. Some of them are forming in clusters, erupting one after the other, almost like a chain reaction. That's where things start to get interesting, because every time one of those flares or coronal mass ejection bursts off the sun, it sends radiation and charged particles out into space. Most of the time, that energy just keeps going. But if the direction is right, if it's aimed at Earth, it can mess with satellites, interrupt radio signals, and even damage power grids. And this isn't theoretical. We've already seen real effects from this cycle. In May 2024, a series of powerful solar storms from active region AR3664 caused significant GPS disruptions in high-latitude regions like parts of Canada and Scandinavia due to ionospheric disturbances. These storms also triggered strong radio blackouts, impacting shortwave communications critical for airlines over the North Atlantic. While no injuries occurred, these disruptions required communication workarounds and raised serious questions about our preparedness for stronger solar events. Now, in mid-2025, we're at the height of the storm. The peak of solar maximum isn't a single day. It's more like a messy season that lasts a year or two. That's why this summer is getting so much attention. Multiple agencies including NASA, NOAA, and ESA have started issuing more frequent space weather alerts. And amateur astronomers, they're spotting auroras in places where they're rare, such as Arizona, France, and even as far south as parts of the Mediterranean region. But even with all this happening, the general public barely hears about it. Unless it causes an outage or cancels a flight, space weather doesn't make the news. It's quiet, invisible, easy to ignore. And that's part of the problem. Because while everything seems fine on the surface, the sun is pushing out more energy, more flares, and more magnetically charged debris than it has in over a decade. It's like living next to a volcano that's suddenly more active. And most people don't even know it's rumbling. This isn't fear-mongering. This is physics. And now that the sun is fully awake, scientists are watching closely because if anything unusual is going to happen, something that challenges the models, it's going to happen. Now, before we continue, if you've ever landed in a new country and immediately gone into panic mode because there's no Wi-Fi, you'll know how frustrating that feels. Either you're stuck paying insane roaming fees, wasting time hunting for a local SAM, or taking your chances with someone selling one outside the airport. I've been there, and it's the worst way to start a trip. That's why I use SY. It's an eSIM app, which means no physical SIM card, no switching tiny trays in your phone, and no standing in line just to get connected. You install it once on your phone, pick a plan for wherever you're going. They've got coverage in over 200 destinations, and the second your plane lands, you're online. It even has built-in privacy tools that block ads, help you save data, and keep your browsing secure. It's genuinely that simple. If we had tried to do this 20 years ago, it wouldn't have worked. The heat, the radiation, the distance, it would have melted the instruments before they even got close. But today, we've built something that can survive there. It's called the Parker Solar Probe, and it's not just watching the sun from a distance. It's flying right through its outer atmosphere. That alone is wild. Most space missions keep their distance from anything dangerous. Not Parker. It's the first spacecraft designed to dive directly into the corona. That faint outer layer of the sun that we usually only see during a total eclipse, reaching speeds of up to 690,000 kilometers per hour to swiftly navigate this extreme environment. To survive that kind of heat, the probe is equipped with a special carbon composite heat shield that can withstand temperatures over 1,300 degrees Celsius while keeping the instruments inside just above room temperature. Since its launch in 2018, Parker has been getting closer and closer with every orbit. By late 2024, it reached a point where it was skimming just 7.3 million kilometers above the surface. That sounds like a lot until you remember the sun is massive. Over 1 million Earths could fit inside it. At that altitude, Parker was literally flying through solar eruptions as they were happening. And then something strange happened during one of its most recent flybys. Parker passed through an active region where multiple CMEs had just erupted. Normally, these coronal mass ejections burst outward like separate explosions, independent events. But this time, something was different. As Parker approached, it picked up signs of an ongoing collision. Not just between plasma clouds, but between their magnetic fields. One CME caught up with another, and the two started merging. That alone is unusual. What's weirder is what came next. Instead of just combining into a larger storm, the merged structure began to compress and warp the surrounding magnetic field in a way that hadn't been modeled before. The magnetic loops above the sun's surface, normally smooth and arched, began to twist downward like tangled rope. One part of the corona folded in on itself. It was like watching waves crash together, but made of superheated gas and magnetism. Parker flew right through it. The instruments on board recorded a sudden spike in particle density, a drop in local magnetic pressure, and a brief burst of radio signals that didn't match any known signature. For a few minutes, the data looked like static until it didn't. When scientists decoded it, they realized Parker had flown through a high-energy shock front created not by one flare, but by the fusion of two. It's being called a compound CME. And while these kinds of events have been theorized, we've never had direct close-up measurements from inside one until now. And it raises questions that go beyond just solar physics. Because when these things happen, they don't stay in the corona. They shoot out into the solar system carrying magnetic structures that interact with everything they touch. Satellites, astronauts, Earth's magnetic field. So now scientists are going back over years of data trying to figure out how many times something like this might have happened without us knowing. Did we miss earlier compound CMEs just because we weren't close enough? Did past blackouts or anomalies